Welcome to 1.3 Modeling with Linear Functions. So 1.3, we are learning to write equations of linear functions using points and slopes. Find lines of fit and lines of best fit. When writing equations, we have a couple options. If you're given slope and the y-intercept, which is b, we use slope-intercept form, y equals mx plus b. This is the most common form we use and probably the one you're most comfortable with. If you're given slope and a point, we use point-slope form, y minus y1, which is the y value of your first point, equals m times x minus x1, which is the x value of your point. If you rearrange this, after you plug it in, you get your slope-intercept form. So these are related. If you're given 2 points, you first need to use your slope formula. Your slope formula, if you don't know it, slope is equal to y2 minus y1 over x2 minus x1. So the difference of your y's divided by the difference of your x's. So let's look at example 1. We need to write a linear equation from a graph. The graph shows the distance asteroid 2012 DA14 travels in x seconds. Write an equation of the line and interpret the slope. The asteroid came within 17,200 miles of Earth in February 2013. How long does it take the asteroid to travel the distance? So they're asking us for an answer. So first we got to come up with a formula, an equation to model this data. So we're going to use, we can figure out slope here. Slope, 0, 0, and it rises 24 feet in 5 seconds. So our slope is 24 over 5, which is approximately 4.8. And we have our y-intercept, which is 0. B is equal to 0. So we get a formula, y equals 4.8 times x plus 0. We don't have to put the plus 0. And they're asking us how long would it take to travel that distance, the 17,200 miles. So we plug that in for y, because y is our miles. So 17,200 equals 4.8x. Divide both sides by 4.8. So x equals approximately, let's make that an approximate because we have to round, 3,583 seconds. So it would take 3,583 seconds to hit the Earth if it was that close. Example 2, modeling with mathematics. We have 2 different venues, 2 prom venues, charge a rental fee per student. So rental fee and a cost per student. The table shows the total cost for different numbers of students at Lakeside Inn. The total cost in Y dollars for X students in Sunview Resort is represented by the equation y equals 10x plus 600. We have a couple things they want to know here. They want to know which venue charges less per student. They also want to know how many students must attend for a total cost to be the same. So we need to figure out the cost per student from Lakeside Inn, and we only have a table of values. So we need to find the slope, and we can do that by using 2 points. So this is, we'll call this point 1, so it's x1, and this is y1. The second one would be point 2, so x2 and y2. So we use our points, or our slope formula. So y2 minus y1 divided by x2 minus x1. So we get 300 divided by 25, and that's 12. So it's $12 per student. So we get, we need to use that. We're going to use point slope form. So y minus y1, and we'll use the first point. So that's 1,500 equals m, which is 12, times x minus the x value, which is 100. Then we're going to solve for y. Distribute the 12. We're going to add 1,500 to both sides. So we get y equals 12x plus 300. So that is the equation for Lakeside Inn. So let's answer our questions now. Which venue charges less per student? Well, oh, didn't mean to do that. I'm going to highlighter. So Lakeside Inn charges $12 and Sunview charges 10. So Sunview is actually the one that has less. So Sunview charges less per student. And then the second question, how many students must attend for the total to cost the same? So we want to know when these two equations are equal. So we take 10x plus 600. We want to know when it's equal to 12x plus 300, and we solve. So we gather our x's on one side, so we'll subtract 12x from both sides. So that's negative 2x plus 600 equals 300. We'll subtract 600 from both sides. So negative 2x equals negative 300. Divide both sides by negative 2. X equals 150. So the answer to that question, at 150 students, the cost will be the same. All right, let's look at number 3. Example 3. We're talking about lines of best fit. So there are certain steps we've got to do. First, you create a scatter plot. Sketch the line that most closely appears to follow the trend. Choose 2 points on that line to estimate the coordinates of each point. And then we need to write an equation to model the data. Okay, we're going to use technology to help us with this today. The table shows the femur length in centimeters and height in centimeters of several people. Do the data show a linear relationship? So that's our first question. If so, we need to write an equation of a line to fit and use it to estimate the cost of a person, or not cost, the height of a person whose femur is 35 centimeters long. So we're going to use Desmos to help us here. All right, so there's Desmos. We're going to graph this table. And to put a table in Desmos, you hit the little plus button, and you use a table feature. And we're going to enter in all this data. So X in the X column, Y in the Y column. I'm going to pause the video while I finish filling this out so you don't have to watch the entire thing. All right, I have everything typed in with the whole entire table. And you notice that we cannot see the graph on the right-hand side because our data, look at our X values. It's in the 30s, 40s, and 50s, and our X axis does not go that far. And our y values goes up to like in the hundreds, almost 200. So we need to adjust by pinching our screen, pinching our axes. I'm going to drag this down to I can see in the hundreds, and there we go. So there's my y values. And if you need to, you can stretch out your x-axis to make it fit better, okay? So the first question, do the data show a linear relationship? And yes, it does. So yes, it's linear. It looks like a line. Okay. The second question, we need to write an equation of the line. So we're going to let our technology do this. So you do that by typing in, now you got to type it in a certain way. Notice how on your table, your x column is x1 and your y column is y1. So we're going to use that information. So you're going to type in y1. Okay. Now, we need this special symbol. It's like a wiggly line. If you hit your ABC button, and right below the B and the N on the keyboard is this wiggly line, okay? And then we're gonna type in M, X. Now we're gonna put in a 1, because we wanna refer to our X values, plus B. So plus our B value. Again, go back ABC button and find the B. And that gives you a linear regression. Okay, this is the line of best fit, not just a line of fit. All right, so there's our equation. The equation of the line is, of our line, we're doing y equals our slope. Our slope is right there, 2.60 times x plus b, and our b is right beside it. So plus, now I round that 2 decimal places, that rounds the 9 to a 0 to 10, and it bumps up, so it rounds to 65. Okay, it rounds to 65. So our equation of our line is y equals 2.6x plus 65. And we can use this to estimate a person who has a 35-inch femur. So you just plug that in, and femur, if you look on our table, femur length is your x value. So I'm going to plug that into our x value. Then I'm going to simplify. And that gives me 157.5. So 157.5, and we're talking about centimeters. Okay. Now I want to talk about something else. Right here is this R. Oh, whoops, that wasn't a highlighter. This R value. An R value is called a correlation coefficient. And it tells you how good a fit is your equation to model your data. Okay, it's never going to be perfect, but we have this scale. Okay, it goes from 1 to -1, with 0 being in the middle. Okay, the closer it is to 1 or -1, the better the fit of the data. So let's label that. So this is a good fit. This is a good positive fit. Good positive correlation. And if it's -1, this has a good negative correlation. Okay? As it ventures to the closer to 1 and -1. If it's at 0, it doesn't have a very good fit. Now, if it was a perfect 1, if your R value is 1, that means every single point is on your line. Okay, nothing is off your line. Okay, but that's usually impossible with real data. So the R value tells you how good a fit your data is. Our R value is 0.9945, which is really good. So this is a really good model for our data. And that is 1.3. If you have any questions, let me know. Bye.